In this video, I'm going to show you how to use a TI-84 calculator to solve systems of equations. And let's start by talking about what a matrix looks like. Now, we're not talking about, the movie here. We're talking about something that looks like this. You take the coefficients of your numbers, 6, minus 5, or negative 5 and negative 45. Coefficients. 2, 2, and negative 4 for the next one. This is an example of a matrix. So the process in using a matrix to solve a system of equations is actually knowing what it is that's going to go into the matrix. Now this system of equations gives us a 2 by 3 matrix because there's 2 rows and 3 columns. Now the steps to using a matrix in a system of equations is listed here. The first thing you're going to do is you're going to go into the matrix program by doing second and then x to the negative 1. Scroll over to the edit menu and hit enter to select the matrix, matrix A in this case. If you want to do a different one, you can. But I usually just use matrix A. Now you enter your dimensions, which in the first example we're doing is a 2 by 3 matrix. And you can see that it changes the number of places we have to enter zeros. The next thing you do is you take these numbers from your equations and put them into the matrix. So I'm going to plug in 6, enter, hit enter in between each one, negative 5, negative 45, and then the second row is 2, 2, negative 4. The next thing you want to do is actually exit out of the matrix. You do that by second mode. Right above that it says the word quit. Then you go back into the matrix menu, go over to math, and you scroll down till it says RREF, which stands for Reduced Row Echelon Form, which basically is going to do the work for us. Go back into the matrix menu and select the matrix you're doing this to. Hit enter again, and we get our solution. Now, the solution needs to be written as an ordered pair or an ordered triple. So let me explain what this looks like. And when we wrote this equation, the first column was our x's, the second column was our y's, and the last one was the answer, the numbers. It's the same thing here. The first column is our x. So this says I have 1x, no y's, and negative 5 on the other side. So translation, x is equal to negative 5. On the second row, there's no x, but there is a y. So this says y is equal to 3. So the solution to this system is the point negative 5, 3. And I'm done. Okay. Now, one thing you do have to be careful of, though, your equations need to be written to where your x's and y's are lined up. So I need to rewrite this one. The bottom one is fine. X then y equals number. But the top one, I have to subtract 8x from both sides to get negative 8x plus 2y equals 18. Then I can go ahead and plug my numbers into the matrix program. So go there, go back to edit. Still a 2 by 3 matrix, 2 rows, 3 columns. Now I can change my numbers. It's negative 8, 2, 18, and then 1. Remember, if you don't see a coefficient, it means there's only 1. Negative 4, and then 24. Always make sure that you didn't make any typos, because the typo is going to mess the whole thing up. So exit out, and then since I've already done this, I can just do second enter without having to go back into the matrix program. And we can see my answer for this system. I'll move it over here so it's still visible. The solution to this system is negative 4, negative 7. Okay. Now this also works on systems with 3 variables. I used these two in my previous video with systems of 3 variables solved algebraically, and this one took a long time. But if I go and use the matrix program, it doesn't take very long at all. So I'm going to go back to edit, but it's no longer a 2 by 3 because now there are 3 rows and 4 columns. So I do have to change my dimensions for this one because it's a 3 by 4 matrix. So plug in the numbers 9, 2, 3, and 170 for the top one, 5, 4, 7, and 173 for the second row, and then 4, 1, 6, and 116.5 for the last. Exit out, perform a reduced row echelon form, and there we go. Now, just like with the previous ones, your first column is the x values, second, that's the y, third is z's, and then the answers are over there. So the solution to this system is 13.5 for x, 11.5 for y, and 8.5 for z. And considering when I did this in the previous example, in the previous video, it took half a page of work, well, this was a lot quicker. Now, what happens if you're missing a variable? I also used this one in the last video. I did it by substitution. Went a lot quicker than that one did, but it still took a while. But what am I going to do for that one? There's no z value. Well, I can write this as 1x plus 3y plus 0z equals 1. You cannot skip over the z value. If you don't see it, it just means there's 0 of them. So when I go to do a matrix for this one, I'm going to plug in a 0 for my third number on that particular row. So go back, still a 3 by 4 matrix, and my first row, I'm going to have the numbers 1, 3, 0 for z, and then 1. Then it's -1, +1, +1, 3. +1, 3, -2, whoops, almost made a typo there, and -7. Exit out, and there we go. I got the same answer as my previous video. So my x value is 1, y is 0, and z is 4. So that's how you perform, or rather how you use a matrix to get the solutions to a system of equations.